Theory and Practice of Silviculture, lecture number 8. In the previous lectures, from lecture number 1 to 7, we have studied about the locality factor, site factor or habitat factor. As we know that the site factor has an effect or influence with the forest vegetation, and it is very clear that the interaction of vegetation and the locality factors affect both. So this is very important what we are going to study in this series, that is forest succession. So this present video lecture will be on the forest succession part 1, where we will going to study and understand about the importance of forest succession. As already I told you that it is very clear that the interaction of vegetation and the locality factors both affect each other. Now we should know the very important of succession, as succession plays a very important role in many of the aspects in forestry. So that is very important. Before we start studying succession, we should know about the importance of succession. First of all, the importance of succession is classifying the forest. As not only in India, in the entire part of the world, there are a lot of forests. So all the forests in different part of the countries, they classify the forest into different classification, like somewhere are scrub forest, somewhere are dry deciduous forest, somewhere are moist evergreen forest. So how to classify it? And succession plays a very important role for classifying the forest, and also deciding the silviculture system. Now silviculture system, I'll be coming in the coming lectures about what is a silviculture system, like to renew the crop, or to harvest the forest, or to tend the forest. So we should know how to do the silviculture system for different species. So succession helps us to decide the silviculture system to be adopted for the management of the existing tree crop. Then it is also important for the artificial regeneration. Now it helps the selection of a suitable species and site treatment for artificial regeneration. Not only this succession also help us indicate us that which species or which community which is very important for us, we should keep that at that desired successional stage. So it helps us for the silviculture operations to maintain that particular community of the forest that we require. So this importance of succession in the beginning I'm telling, in the last also I'll be going to tell, but we should know why we are studying the forest succession. Now what is succession? Succession is actually the replacement of one set of a biotic community or biota by another set of different nature. You can see this is one community of forest, and it is the another one here, this is the another one here. All they are different with each other in their nature. So replacement of one community with another and another community with another, this replacement is called succession. So it is a change in the species composition of a forest, but very slow. It is not a rapid change. It takes a lot of years for the replacement of one community to the another community. So it is called succession. So this change in species of a forest is slow but continuous. So we can say it is dynamic. Now let's go back to succession once again. It is the gradual replacement of one community by another in the development of vegetation towards climax. Now what do I mean climax here? Climax is the culmination stage in the plant succession for a given environment. Culmination means now further there will be no other change, no other replacement. So we can see it takes time. So in the beginning it is some species which are coming, are pioneer species which are replacing this community is replacing with the another community, and this is replacing with another community. A time comes when there is no replacement. It is called culmination stage, or it is called climax. So we will understand by the word called Siri. S-E-R-E, SER. So what is SER? SER is the series of plant communities resulting from process of succession or any recognizable stage. Now what I mean here is a recognizable stage. You can recognize here when this in the pioneer stage comes, you can recognize this as a xerophytic or as a tree species more light demanding. Then this pioneer is replacing some other species, other different nature which is coming here, which you can recognize what type of species it is here. In the coming time again they are replacing the other species. Similarly they are keep on replacing the species. This replacement or this different stage, this different recognizable stage where you can recognize it is called series. Now let's understand more better this one. Before that one, I want to give two terms, that is called, one is called autoecology and one is called synecology. Now what is autoecology? This autoecology, when I want to say, it is just like in the beginning it happens, and when I say synecology, it is just like in a climax it happens. Let's go back and just understand. When I come to this in the beginning stage of any succession, we can say autoecology, and when I come to something at the end of that stage, like in the culmination stage, we can say it is a synecology. Now the study of an individual organism. Now here autoecology is like an individual organism in relation to the environment, called autoecology. It is a study of an individual. You can see the individual organism in relation to the environment, like your rainfall, like your temperature, like your wind, like your side factor there. So that relation with the environment is called autoecology with the individual organism. But when it is synecology, means there is a community now. So you can, the forest community. Here the study of the community and their interaction, we can say, is a synecology. So that's the difference between autoecology and a synecology. So before succession, some concepts of succession we should clear it. I want to say like that Adolphe was the first to make the use of forest succession, and then you can say Henry in 1859, Henry David Thoreau, the succession of forest trees, oak, pine, was written by this Thoreau. Then Collins, as 1899, Collins described the change in vegetation on sand dunes, and Clemens 1916 developed a descriptive theory of a succession and advanced in a journal ecological concept. So these are the very renowned foresters or scientists which have given the concept of succession. But basic feature and concept of plant succession, we have just make us a bit clear about the concept. Now succession, again I am telling, succession is a continual change in vegetation, and as a result of interaction of plant community and their habitat. So it is a continual change in the vegetation, but what result of interaction of plant community and their habitat factors. Number two, progressive, and the end progress is climax. The end product of succession is climax, and this progressive development of vegetation of the same site in a course of time. So it takes course of time. So for example, here's a pioneer species, a bare site was here, some species has come here, pioneer species coming the first. So this pioneer species is been replaced by the different plant community here in a progress of time. Again, this same place, it is not like that species are traveling from here and reaching the climax. It is the same place. The same place, the same site, the course of time, one nature of vegetation is changing the another nature of vegetation. So this way they keep on replacing in the course of time, and this progressive development of vegetation, it comes to a climax. Now SER. Now I'll come back to SER again back. SER is the series of plant communities resulting from the process of succession or any recognizable stage in a plant succession. The series stage of the succession are called, this series of stages in succession are called series. What is series? There are four stages actually. One is, we call it a pioneer stage, another one we'll call a consolidation stage. This consolidation stage will also include serial stages. Now I say a word called serial stages. I'll be clearing these serial stages, and these are very important stages in plant succession. Another stage, third one, is called sub-climax, and the last one is called climax stage. So some worker has recognized 4 stages in series. This series may be different type. Stages are very different. Like the first stage is called pioneer stage, is the first which occupy the space. That site, that space, the species which occupy the site is called pioneer stage. So it is the primary stage and it occurs in the bare site. Next series is consolidation stage. This consolidation stage, when the soil condition improves in the same site, one species will replace the another plant community, another plant community will replace another plant community. It will take some time. By the process of this time, the soil condition improves, and the species are also set in replacing one species with another completely, the pioneer species. This process will improve the soil condition, called consolidation stage. The third one is called serial stage. Now this is serial stages. Now, what is serial stages? Serial stages is referred to the developmental stage now, because it helps to develop the stages. One plant community will replace the another plant community which is more better than the previous plant community. So this is called developmental stage in vegetation forms. The vegetation consisting of the stage keep on changing due to reaction with the environment. Now this reaction is not a chemical reaction. This reaction I will be also explaining in the coming lecture. So the another stage before climax is called sub-climax. So a sub-climax is a stage or in a succession just before climax stage. And what is the climax stage? Climax stage is the culmination stage. The last stage is called climax stage. Well, let me come back to pioneer stage. So again I'll say this definition of pioneer stage. Pioneer stage refers to the primary stage when the bare site is occupied by vegetation. The species which first occupy the site are called pioneer species. So this is a bare site where the first time the species which may be very hardy, which may be very xerophytic, which may be in a grass form, they occupy the site in the beginning is called pioneer stage. So this is very important stage in plant succession. Then is consolidation stage, when the soil condition improves. You can see the soil conditions are improved here. So it is why? Just because the species either replacing completely the pioneer species which improves the soil conditions. These are the pioneer species, and these pioneer species are being replaced by some next community as a part of succession, and again this has been replaced by another community as a part of succession. So the soil improves. So soil condition when it improves is called a consolidation stage. Again I say, don't be confused. It is not the species or trees are traveling from this side to this side. It is the same place. It is the same place where the species are replacing with each other. The plant community, one plant community is replacing the another plant community, and another plant community is replacing the another plant community. So the same site keeps on improving, the soil condition keep on improving is called consolidation stage. Serial stages now refers to the developmental stage in vegetation forms. The vegetation consists of the stage keep on changing due to reaction with the environment. Again I say reaction, I'll explain you reaction. Now serial stages. Now just see, this is the first pioneer stage coming here in the beginning, and this pioneer stage is been replaced by the another plant community which is called early serial. This early serial is been again replaced by some another plant community called mid serial or late serial. So before reaching climax or sub-climax, those plant community which are coming in between are called serial stages. These are the developmental stages, developmental to the climax. So that stages are called serial stages. Sub-climax. So a sub-climax is a stage in succession where just before reaching the climax community. So this is first pioneer which has been coming up, and it has been replaced by early serial, maybe replaced by mid serial, maybe replaced by late serial, and then it has been replaced by a species, a community which is similar like climax, but we call it sub-climax still. This sub-climax has to further go on developmental stages and then reach to a stage where further no changes happens, and that is called the climax stage, this climax stage. So climax stage is the culmination stage in the plant succession for a given environment. At that particular environment, now the vegetation there, the tree species there are tolerant with that particular climate, particular environment. Now further no changes are happening. No other plant community is replacing that plant community. It is the culminating stage, or you can say the last stage is called climax. Now here the vegetation is in equilibrium with the side factor and becomes stable now. So they stay unchanged indefinitely by reproducing itself. So that is called a climax stage. So these are some definitions which you understand. And now in the entire plant succession or forest succession, we should understand what is retrogression. So retrogression, which is defined as the revision to some earlier stage of succession consequent on the introduction of an adverse factor. What are those adverse factors? That adverse factor may be fire, maybe clear felling, maybe drought, maybe grazing. There are some adverse factors which is happening there and not letting the plant succession or forest succession to proceed further. It has stopped there. Not only stopped there, it is making rivers going back. So when it goes back, these stages, so this you can see, this is a very good tree species here. What happened? Fire happens here. Maybe lot of uncontrolled grazing or felling of trees or some other development work has happened here. So not letting the trees to replace or to settle down or to establish there, rather it has made revision to what? To some earlier stage. It has gone back to earlier stage, which is not coming back. If we stop all this process, again the succession will start from there. But when it doesn't happen, then a tree species, they become more xerophytic, or the plant which is available there becomes more xerophytic in nature. So what happens? Stage is pushed back to several stage earlier. It goes back like a pioneer or like a bare site. So that is called retrogression. Now, there are two theories we should understand before I start forest succession. One is called Monoclimax Theory, and this was developed by Clements in 1936. This theory recognizes only one climax, determined solely by climate, he says. Clement says just because of this climate only the succession happens, or there is a climax which comes just because of the climate. The theory pointed that all serial community in a given region, if allowed sufficient time, would ultimately converge to more or less in a single stable climax community. So maybe light, maybe temperature, maybe rainfall, maybe humidity, all those climates only. So that climate has, this theory was named as Monoclimax Theory. Many were not very satisfied that not only climate is only the sole responsible for the climax community. So there is another theory called Polyclimax Theory. So in a given climate, different vegetation climaxes are known to develop. So different type of climaxes comes, not only just because of that climate as Clement has given. So they say that different climaxes depend on soil, edaphic factor, topographic factor, biotic factor. So there can be more than one climax community in a one given climate. That is called polyclimax theory. Polyclimax theory now is widely adopted. Various type of climax like climatic, edaphic, topographic, biotic are recognized. So this is called polyclimax theory, and now it is more acceptable theory. Now, kinds of succession. Before we start the forest succession, we'll understand about the kinds of succession. So there are two kinds we'll be discussing now. First one is on the basis of moisture condition of the place. So on the basis of moisture condition of the place, one is called xerox succession, initiated in extremely dry situations like these bare rocks or wind-blown sands. The different stages in this succession, so there are different stages in any succession called shear, or here it is called zero shear, which originate on rock surface, and semoshear, which originate on sand. On the basis of moisture again, another one is called hydraulic succession. The succession beginning in water or very wetland in ponds, lakes, marshes. The various stages of these successions are called hydrosear. So shear means again different stages of succession proceeding to the climax. So in between that stages are called shear. So here it is called hydrosear for that one. You can see there is some wetland here. So in wetland here the succession as a pioneer will start, and these are some you can say some stages after pioneer stage like serial stage, and something it will develop, and slowly it will reach to climax. Now another succession is called on the basis of the presence and absence of vegetation. This will be studying in detail. Kinds of succession on the basis of presence of or absence of vegetation. There are two. One is we call it primary succession, other one we call it a secondary succession. So we'll study the both in detail in this video lecture, that is a primary succession and secondary succession. What is primary succession? Also it is called autogenic succession. So we have to remember in an exam if it comes what is primary succession, another name for that one you can say it is an autogenic succession. So the succession which takes place on the site which have previously not borne vegetation. So in a new site there were no vegetation earlier. So that succession which comes in the bare site or on a new place, on new site, that is called primary succession. So primary succession may takes place as a result of the reaction or autogenic factor. So I told you it is also called autogenic succession. Next is called secondary succession, also called allogenic succession. So the succession which takes place on the site after destruction of the whole part of the original vegetation, means that there were vegetation earlier, there were trees earlier, forest earlier, maybe due to some adverse factors like burning or clearing or felling or grazing or erosion, landslide, any adverse factor has destroyed the forest there. And again the forest has started there, starting from pioneer, serial stage, then sub-climax stage, climax. That succession is called secondary succession here. So it is also called allogenic factors which has happened there. First of all, we'll study about the causes of primary succession. Now what is the cause that primary succession happened? There are two causes, and that we have to understand one by one. There are two set of distinct cause of primary succession. Number one is called initiating cause. Number two is called continuative cause. Now first let's understand what is initiating cause. Now initiating cause in a primary succession may happen just because of the erosion or deposition of eroded material like sand dunes, alluvial deposit, landslips, or moraines from rocky deposit due to a glacial deposit. From glacier, that rocky mass of rocky deposit happened there. then seismic disturbance, coastal or estuarine deposit, maybe some different type of physiographic or climatic factor which happens, which creates that new area. That is called initiating cause. So initiating of a primary succession. Again, let's see this small diagram. I said that initiating cause of a primary succession may be a base, a bare area which has to be developed. Then only the site where new vegetation comes is called primary succession. For example, that this area, this bare site may be due to this landslips or screens. Screens means the stones, rocks and everything coming from the top hill, and due to some seismic disturbance, maybe due to some landslide which has come up, and a site or a place has been developed where nothing is there, where even nutrient quality is very bad, where water holding capacity is not there, because this due to landslips, screes, seismic disturbance or deposition of eroded material, alluvial deposit, erosion from here, whatever the site which is now been ready, which is bare, may be very difficult, or maybe very not suitable for a vegetation to grow. That bare site is the first initiating of a primary succession. We can see here. For example, you can see the vegetation is in the top, where still in the top layer we can see some of the soil is suitable for the plant to grow. But when we go in the material, parent material, here this is a soil which has not been ready, or it is not a soil which is very much fertile. So this area, or we can see the scree, where you can see this mountain or this seismic disturbance, all the scree has come down. You can see the entire place which has been now a new bare site which is there to start for the primary succession, the initiative cause. Just you can see this is the entire scree where the succession has to start if there is no disturbance, starting from pioneer stage. You can see this is the entire site just because of the landslide, because of the scree, because of the erosion, or there are adverse conditions where the site is now ready enough, where the primary succession as an initiative cause has to start. But here there should be seed dispersal in the beginning, maybe by wind, maybe by water, by animal. In the bare site, then only succession will start. Like we can see one example, this is one tree species which is trying to come up as a sapling, is called Dobanga grandiflora. So it is in the bare site which is coming, where we should understand that those species should have a viable seed, because the site is not very good enough for us to support the vegetation. And that species which is coming in the pioneer stage or in the cereal stage should easily germinate. They should have a massive root system. They should have a low water requirement or a nutrient requirement. They should fix nitrogen. So in the rocks we can see here one species coming called Chucrasia tabularis. You can see also one, this is Terminalia chibula also coming up, maybe due to the animal dispersal. Here we can see again the Dobanga grandiflora coming here. So this type of species should tolerate the stress. They should have a drought resistance, then only they can come in the primary succession, in the initiating causes. You can also see this is Bahunia coming here in the rocks. You can see they should be very frost hardy, bear strong sunlight, then only they can come and start. So that is what we can see, that's how succession has to be started when there is no disturbance in that area. And even if you see, if it's a water course coming here, so water course, when it is coming here in these sides, we can see the water course, but on the other side we can see that there is no such disturbance. The succession will proceed from here. You can see the succession will start proceeding in this bare side here. So this way the succession, you can see that how the shrubs or this have started in this sides of the river, and then slowly this community, plant community, will be replacing each other. They will make a site better consolidation stage, you can say. The soil will be developed here, because when they keep on, animals will keep on dying and then keep on adding soil organic matter, the soil condition becomes better for the other species to come here. So succession keep on starting. It is not very rapid. Succession may take hundreds of years to get it. So after initiating cause, next is called continuative cause of primary succession. What is continuative cause? There may be some stages of continuative cause which helps in the development and replacement of one community with another. After initiating cause, after the bare site is now there, we will go for the continuative cause in the primary succession. So there is migration, accesses or establishment, grouping, aggregation, competition and reaction. So let's understand this continuative cause of primary succession. First, I say migration. Migration means in that bare site, at least those seeds or those cuttings should be coming or is been dispersed from that area and coming in that area. It has to be migrated. Seed has to come. So seed should be easily germinated, seed should have a viability, seed should be able to disseminate through wind or water or through animal, so that can come in that bare site is called migration. So there are species like Bombex Siba which can be migrated through wind, like your Adena, like your Holopetelia, like your Acacia, Dalbergia through water. So these are the some dissemination, or these are some source of dispersal of seed. So after that migration, next stage is called establishment. Establishment, now the seeds which have germinated, some few pictures I have shown that how they have germinated. After germination, they have to come up to build up their capability to become a sapling, then a pole, then a tree, and then they are able to reproduce in that area. So that is called establishment. They has to be established here. So they have to come from a sapling to a pole and a pole to a tree, and then they reproduce so that they germinate in that area. It's called establishment. And after that establishment, this community will replace another community and they will come in a grouping. So when grouping comes, means now the lot of plant community is starting settle down there. It's called grouping. The third stage of continuative cause of primary succession is called aggregation or grouping. Then there is a fourth stage called competition. After grouping, they will compete with each other. In competition, law of nature says survival of the fittest. So competition will come up there. Different species will compete for light. They will compete for space, they will compete for water, they will compete for nutrients, and the survival of the fittest will be there. So this competition will be the continuative cause after the grouping. We can say the fourth stage is called competition here. Now I was talking of reaction. Now what do I mean by reaction here? So reaction is the effect of vegetation on the site. I repeat it back. Reaction is the effect of vegetation on the site. Now there are two things: effect on climate factor, effect on soil. Now what is the effect of vegetation on the site, on the habitat, on the locality factor, we can say. So first effect is on the vegetation effect on the climatic factor. So after competition on grouping, the trees, they will make one environment. Like inside the forest, the day temperature will be reduced in the daytime, because inside you'll feel bit coolness, and the night temperature will increase in the winters inside the forest. So it has an effect on the climate there. Then it will reduce the wind velocity. So you can see the reduce in the wind velocity inside, because the trees will obstruct that wind. Then even there's a forest canopy cover there, which will also help to fight against frost. So there will be less effect of frost inside the forest. Then the light is also reduced inside the forest. So effect on climate factors even include the humidity. So relative humidity inside will be more as compared to the outside the forest. So see how the trees and vegetations, they have given an effect on the climatic factor. Not only that, effect on soil also, we can see it has improved the structure of the soil, because there is addition of organic matter. Every year the leaves will fall down, every year the branches will fall down, they will decompose, so they will add organic matter to the soil, improve the structure. Not only structure, it improves the nutrient status of the soil, so you can have a nutrient cycling itself. The nutrient cycling will set up there. Not only that, due to this organic matter and improvement of the structure of the soil, there is a moisture retentivity there, water holding capacity will be more better. So this way there is an effect on climatic factor and soil by your forest vegetation there, called reaction. Now this is the causes of primary succession: initiating cause and then continuative cause. Now let's understand about the causes of secondary succession. Again, there are two types. One is called initiating cause for secondary succession and continuative cause of secondary succession. Well, initiating cause may be a bit different as compared to your primary succession. Initiating cause of a secondary succession may be destruction of the existing vegetation, because already due to primary succession you have vegetation. This vegetation of primary succession may be destroyed by your adverse climatic factors. Maybe your climatic factors like drought, flood, wind, snow, frost. Maybe this vegetation has been destroyed by your landslides or erosion or burning, cutting, grazing, or many other things where the existing vegetation has been destroyed. This is called the initiating cause of secondary succession. As you can see, there's a forest fire, already the trees and vegetation was there. It is not like primary succession bare side. Already the forest was there, it has been destroyed by your fire or by a flood, drought, wind, landslide, or any other adverse factor. The forest has been destroyed where your soil was already developed, already mature soil was there. So this is called initiating cause of secondary succession. You can see that soil already been developed, forest was there, burning happened, and all the vegetation has been destroyed. Now this is called initiating cause for secondary succession. You can see this is one area where shifting cultivation has started, and due to that again vegetation is destroyed. Here shifting cultivation where something happens is also called secondary succession, where it started here. You can see slowly the vegetation has come out in the same place, but it is not that the same vegetation will be there as it was previously here. So this was the initiative cause of secondary succession. Let's come to the continuative cause of the secondary succession. Now secondary succession is similar to the primary succession. Those causes like migration, establishment, grouping, competition, reaction, they are similar to the primary succession. Let me repeat it back. We will have migration in the secondary succession where forest was destroyed. Obviously the seed or the cuttings which has to come from the different places and has to come in that site which the forest has destroyed. Then these seeds will germinate, sapling will become to pole will become to tree will again reproduce. This is called establishment, and then this establishment phase slowly will replace one vegetation to the another one called grouping, and then the grouping will come up to competition. Well, competition, survival of the fittest will be there. The tree species will be competing for light, for space, for nutrients, and then this competition will go for a term called reaction. Already I explained, reaction is the effect of vegetation on the site, where I mean to say that the vegetation itself will have an effect on climatic factor and a soil factor. Climatic factor may reduce the wind, which the wind velocity will be very less inside the forest. Day temperature will be reduced inside the forest. Night temperature will increase in the forest. Light will be very reduced inside the forest. Relative humidity will be increased inside the forest. So this how they change the climatic factor by the forest vegetation. Even the soil factor is been changed, like it improves the structure of the soil by addition of organic matter, improves the nutrient status of the soil, also the moisture retentivity of the soil. Thank you very much. My next lecture will continue, and that will be on forest succession part 2, where I'll be going to explain the requirement for the natural regeneration. Thank you.